Welcome to my AP Chem free response presentation. Today we will be looking at the 2019 AP Chem free response question 4, A through D. So a student is doing experiments with CO2 gas. Originally, a sample of the gas is in a rigid container at 299 Kelvin and 0.7 atmospheres. The student increases the temperature of the CO2 gas in the container to 425 Kelvin. A. Describe the effect of raising the temperature on the motion of the CO2 gas molecules. B. Calculate the pressure of the CO2 gas in the container at 425 Kelvin. C. In terms of kinetic molecular theory, briefly explain why the pressure of the CO2 gas in the container changes as it is heated to 425 Kelvin. D. The student measures the actual pressure of the CO2 gas in the container at 425 Kelvin and observes that it is less than the pressure predicted by the ideal gas law. Explain this observation. This time pause the video because we will be going over the answers shortly. Okay, we're going to move on to the answers. 4A. Describing the effect of raising the temperature on the motion of CO2 gas molecules. So the average kinetic energy of the CO2 molecules will go up as the temperature goes up. The molecules will move more rapidly and they will collide more frequently with each other and the walls of the container. For B, we will be using Gay-Lussac's law. So we'll put the initial pressure over the initial temperature and the final pressure over the final temperature. So we'll go back and we see that the initial temperature is 299 Kelvin, the initial pressure is 0.7 atmospheres, and the final temperature is 425 Kelvin, so the only thing we don't have is the pressure. So we plug these in, and we end up with the final pressure being 0.99 atmospheres. Okay, for C, we see how the average kinetic energy of the CO2 molecules, how that increases as the temperature increases. So that means that there's going to be more collisions of the particles with each other and with the walls of the container. Pressure is the net effect of the strength of the collisions of gas particles with the interior of the container. When those collisions are stronger and more frequent, the pressure is higher. Okay, moving on to D. The ideal gas law assumes that gas particles have no volume and exert no attractive or repulsive forces on each other. We know that that is not true because these are not don't match real conditions. We can expect deviations, namely because the pressure is lower than that predicted by the ideal gas law. We can assume there is some significant attraction between CO2 molecules. So that is why we will see a difference in the actual observations and the predicted pressure using the ideal gas law. Good luck, everyone. I hope this video was helpful. Thank you for watching my video.